Hello, my name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we are working together. Today is our lesson number 25. We are on page number 93. The very first problem that you see on the page is already on the blackboard. I'm going to read the problem to you, then I'm going to get out of the frame as usual. I want you to pause the video, do the problem yourself first, and then we'll compare your work against the work that we'll do together. Do you understand? You know the routine. Here we go. We are told that in a correctly worked out addition problem, it is an addition problem right here. It is worked out correctly. We are told that P, Q, R and S. P, Q, R and S. These are all digits. We are further told that Q has to be 2 times P. Q is equal to 2 times P. The question simply is, what could be the value of S? And these are the possible answers. 3, 4, 5, 7 and 9. What could be the value of S? Do it yourself. Pause the video as I said. Let's begin, shall we? The very first thing we must keep in mind, very first thing we must understand in this thing is that these quantities that we're talking about, P, Q, R and S, we are told that they are digits, which means their value, whatever the values are, whatever the values of these four quantities are, these four P, Q, R and S, it has to be between 0 and 9. For example, we cannot say that R is equal to -1 because 5 minus 1 will give us 4. Because how can a digit be negative? It has to be positive and has to be between 0 and 9. It cannot be 12, it cannot be 13 because they are digits. The second thing we will have to keep in mind is this very important bit of information that is given to us, that Q is 2 times P. Let's begin. Because without it we will not be able to solve it, which is exactly why I erased it. I believe that's what it says, Q equals 2P. Okay, let's begin. So I'm just going to rewrite it so that we have more room to work with, and then I'm going to erase this part. So here's the problem. We are told 3, P, 5, 4, Q, and R, and this is 4, this is S, and this is 8. Let's begin, shall we? So as we already established that they are digits and therefore they cannot be negative, and yet we have a 4 here. The only way we can get a 4 here, and it also cannot be, it can be 9. The only way it will work is that R is equal to 9, and in which case 5 plus 9 is 14, 4 and will carry 1. R can be 9, but we cannot claim, but R cannot be 99 obviously. Do you understand? That would not work because it's a digit. So we did that. That part is already done. Here is the next important bit. This is the most important step. This is the most crucial step to understand here. So we see that 1 plus P plus Q, 1 plus P plus Q, and here we have S. But 1 plus P plus Q does not equal to S. What we need to understand is that in the hundreds column, the last column, in the hundreds column, we have a 3 and a 4 and yet we have an 8. The only way we can get 8 out of it with a 3 and a 4 is that we must have carried 1. We must have carried 1. In other words, 1 plus P plus Q is not just S, this digit there, but it is S plus 10. For example, 1 plus P plus Q could have been 13, in which case S is 3 and then we carry 1. Or 1 plus P plus Q could be 17 and that's a 7 and carry 1. That 1 is not a 1, that's a 10, which is why we have a 10 here. 1 plus P plus Q must equal S plus 10. Now we make use of this thing. Q equals 2P. So I'm just going to, instead of rewriting the whole thing, just replace Q with 2P. There we go. Take out the 1 from here, that becomes a 9. And what we find is that what this tells us is that 3p equals s plus 9. Let's continue this from the top. We need the room. I don't want to keep working with the bottom here. We're going to pick up from here. We're going to pick up this equation right here. 3p equals s plus 9, which in turn implies that s must equal 3p minus 9, and that in turn implies that s must equal 3 times p minus 3. Make sense to you so far? And since we are interested, the question was which of the following could be the value of s. Since we are interested in s, that's what we have here. But what is this a useful information? The answer is yes, a resounding yes. It's a very useful information because what we just established is that s, whatever it is, whatever the value of s it is a multiple of 3. This quantity is a multiple of 3 because s equals 3 times some other quantity. Since we established just now that s is some quantity that happens to be a multiple of 3, we know now the answer cannot be 4, 5, or 7. We just have to play with 3 and a 9 and see which one works. That's exactly what we're going to do. We're going to play with them and see which one works. Let's begin, shall we? So s is going to be either a 3 or a 9. If s is equal to 3 or s is equal to 9. If s is equal to 3, we also know from this equation that s is equal to 3p minus 9. You with me so far? That implies that 3p must equal s plus 9. That in turn implies that 3p must equal 12. If s is equal to 3, we are working with this situation. And that in turn implies that p is equal to 4. So that's one possibility. Let's see what we have in the other part. I shouldn't have written the 12 here. I'm going to erase it. You understand it. We don't need it. Just so that we have a nice juxtaposition of the two situations. Now we are dealing with a scenario where s is equal to 9. Let's see what happens. We just got as we said, we're going to play with it. See what happens. Again, the same story using this equation right here. S is equal to right here. S is equal to 3p minus 9. 3p minus 9. That in turn implies same as before, same steps as before. 3p must equal s plus 9. But we are working with the assumption that s is equal to 9 now, which means that 3p must equal 18. That in turn implies that p must equal 6. But here's the problem. If that is true, then that in turn would imply that q, which we are told is 2 times p, would have to be equal to 12. Because we were told, I erased it, but we were told that q is equal to 2p. That was a very important bit of information. And that does not work. How can q be 12? 12 is a digit. How can it work? Q is a digit. A digit cannot be 12. But here it does work. If p is equal to 4, q can be 8, and everything, as we say in the desert, is hunky-dory. I'll see you tomorrow. Bye now.